I promised you that we'd do a little introduction to Arduino properly, and that's exactly what this is going to be. We're going to keep this pretty on the fly, unedited, raw, and we'll just keep it fun. I'm not going to spend a whole lot of time getting fancy, but what is Arduino? So the short and skinny of it is Arduino is an open source project that is made up of hardware components, some software languages, a development environment, and a community of people who are trying to make microcontroller development easy for people like you and me. The Arduino project has released lots of different hardware boards, and for the sake of conversation, as far as this video goes, it doesn't really even matter what variant of board we're talking about. You could be using something like an Arduino Nove, which was a board a few years back that was very popular. It could be an Arduino Uno, it could be a Mega, a Nano. It doesn't matter. Arduino has a very straightforward architecture, and I want to talk about that architecture here a little bit. And I'm not necessarily talking about hardware and chips here. I'm talking about workflow and concept as much as I am anything. So we've talked about hardware. So at the core of the hardware is an ATmega chip, generally. Now, there can be other microcontrollers or other MCUs that could be at the heart of it, and I'll leave that for a different conversation. But let's say, for example, we're sticking with the standard stuff. We're going to have an ATmega CPU here. And the ATmega CPU is going to have a TTL serial interface, transistor level logic here. And it's going to connect to either a RS-232 serial interface, which could be anything like a MAX 232 chip or any number of other ways of doing that, or it could be USB. If it's USB, it's going to go through something like an FTDI chip, which is a TTL serial to USB converter. There are a number of other variants of TTL to USB converters out there. Doesn't really matter which one you're using. Obviously, you're going to have to load the appropriate driver for the chip you're using and for the operating system you're using. So we're going to leave that as another conversation and just say that we've got a USB interface through whatever chip that's going to hook up to your PC or Mac. Now, your PC or Mac is going to be running the Arduino IDE, the Integrated Development Environment. The ATmega chip, or the hardware piece of this, in fact, let me draw kind of a box around the Arduino hardware. We'll just put an A here. The ATmega chip is going to have a bunch of different I/O lines. So you could have input, got to be able to spell here, input or output lines. And these input and output lines could be either analog, we'll say analog, or digital. Now, this architecture is to some extent configurable. So, for example, you can use some analog pins as digital pins, if you will. What I want you to take away from this is simply that Arduino is made up of the IDE, it's made up of the hardware, and we've got some general purpose I/O lines that are being driven by an ATmega or other microcontroller, and that this is all connected to your computer via a serial interface of sorts. Once you understand this, the rest of it is pretty basic stuff. So let's jump away from my nasty handwriting here and jump into the Arduino IDE. On my document camera, you'll see that we have a little microcontroller, and he is sitting there, turned on, and he's got some lights on and some LEDs. He's got a green power LED. He's got a blue LED that happens to be blinking every, 1/5 of a second. It's running some code. Now, the code I wrote in the Arduino IDE, and that's what I'm showing you right here. In fact, if you want to know, that's an Arduino Nano variant of the Arduino microcontroller. What I'm going to show you here is going to be the same, whether you're using a Arduino Nove, an Uno, a Nano, a Mini, doesn't matter. Within the IDE, you're going to see a sketch. Now, the sketch is the code that we're going to write and upload to the Arduino. There are a bunch of basic sketches, examples, if you will, that come with the IDE, and I would encourage you to look at them and upload them and play around with them and see what they do and how they do it, and use that as a learning reference for yourself to learn how to write apps or sketches for the Arduino. Now, there are two sections here within the sketch. The first section, and I'll tell you right now, I am not a programmer. I'm not an application developer. I hack on code and understand just enough of this to be somewhat sloppy and dangerous. So don't take my misuse of terminology to mean that I'm an idiot, because it already does mean that I'm an idiot, because this is just a hobby. I am not an expert. If you blow your neighborhood up, it's not my fault. Okay, so we've got two functions here. Setup and loop. Setup is going to run once. It's going to run when the chip gets powered on, or when the Arduino gets powered on. Setup stuff is going to take place here. So if I want to do something once, right when the Arduino turns on, I'll do it in setup. Like if I want to define a pin as an input pin or an output pin, I'll do that one time. I'll do that in setup. If I want to perform an action, turn a light on or off, check to see if a button has been pressed, take a reading from a sensor, etc., I'll probably want to do that iteratively over and over again. So we're going to do that within the loop function. So let's go into setup. Let's write a basic sketch to make a light blink. Very similar to what you see happening on the Arduino on the document camera, except we're going to make it blink a little bit slower. So inside void setup, we're going to say pin mode, and then we're going to say 13, because that's the pin that onboard LED happens to be connected to, is an output. All right, that's the only thing I'm going to do in setup. Down here in loop, I'm going to say digital write 13, again, the pin that I'm using, high. Now, for those of you who don't have an electronics background, think of high as positive voltage logic. It's a signal. It's a digital signal. A pin is either high or it's low in digital electronics. For sake of argument or sake of conversation, let's say that high is 3.3 or 5 volts and that low is 0 volts. So we're going to say apply 3.3 or 5 volts, whatever is appropriate for this hardware, to that pin, i.e. set the pin high. And then delay 1,000 milliseconds, or 1 second. There we go. Next, we're going to do a digital write 13, low. So now we're saying apply 0 volts to the pin. Delay 1,000. So here's what this code would do. When we first run it, we're going to go into setup and we're going to define pin 13 as an output. We're then going to go into the loop. We're going to set pin 13 to high, and we're going to pause for a second. We're going to set pin 13 to low, and we're going to pause for a second. And then we're going to go to the beginning of the loop and do it all over again. I'm going to go ahead and click verify, which is going to check for some syntax errors in my code and warn me if it sees any problems. We'll call this Josh Blink. Wants me to save this sketch. It's going to compile it and make sure everything is in order, which it has done successfully. It says done compiling. I'm going to click upload. Now, if you look at the document camera, you're going to see the LED blinking kind of fast on the Arduino. That's the code uploading. That's actually the serial data transfer. Excuse me. It's actually the serial data transfer happening. Once the serial transfer is done, the microcontroller will reset, and it'll start to execute the code we wrote. So you'll notice now that if you look at that blue LED, it is rhythmically blinking on and off 1 time per second. Let's slow it down a little bit more. Let's make it 5 seconds. I'm going to set that delay to 5,000. We'll hit upload. We're going to watch it blink fast as the serial data transfers to the microcontroller. It will reset, and then you'll start seeing the blinking happen in 5-second intervals. So it'll be on, it'll stay on for 5 seconds, it'll be off, it'll stay off for 5 seconds, and so on and so forth. Now, I could do something like this. I could say be on for 3 seconds and off for 100 milliseconds. And it's going to give you a slightly different rhythmic pattern. So there you go. Now it's following the directions that we just wrote. This is a great example of a basic Arduino sketch. There are tons of things you can do with this hardware, from reading values from sensors to driving interactive displays to audio to just anything, whatever the mind can think of, interfacing the digital world with the physical world. So I'm not trying to make you an expert. I'm not trying to school you on the best ways to write code. I'm not trying to tell you that this is the most appropriate tool for every job. I'm just here to show you a little bit of what's possible using this hardware this way. Thanks for watching. Hopefully you've learned a little bit about Arduino and how to get started and kick the tires. Again, lots of different types of Arduinos out there that you can choose from. And we've only really scratched the surface. I've shown you one of them tonight. Let me drop a couple of others here under the camera just to show you what we've got going on. So this is an Arduino Ethernet. It's kind of an interesting little Arduino. We've got a power supply on here that'll let me get power over Ethernet from it. And it's got pretty much the same form factor as the Uno or the 2009. Here's another one called a Mega. The Mega's got a whole shit ton of input and output lines, so it's useful for when you need a microcontroller that has more I/O lines. On the complete opposite end of the spectrum, I think they call this the Beagle. Or the Beetle. No, that's called the Beetle. It's just a teeny little thing. In fact, the USB interface is built into this. This is a 32U4 18 mega chip, which has built-in USB, so you don't have to go through that whole TTL serial conversion thing. But it's got a USB key. This thing will literally plug into my laptop, and there's an Arduino. Now, I've only got a couple of I/O pins broken out, but maybe all I need is a couple of pins. So, there's no such thing as one size fits all with Arduino. There are lots of variants that do lots of different things. But the beauty is that code you write on one can port to run on another very easily. That's all I've got tonight, guys. Thanks for watching. I hope this has been useful, and I'll see you in another episode of Practical IoT.